Hello everyone, this is Fahad Mirza and I welcome you to my channel. Snowflake has just dropped yet another version of their very fine embedding model called as Snowflake Arctic Embed model. This new version is version 2 and that is what we are going to install locally and we will see how it works. Equally important, I will also be describing why I am using a special transformer for this model instead of our usual Hugging Face transformer. As is the spirit of the channel, I will be describing these concepts in very simple words, and I'm not expecting you to be a machine learning guru or anything like that. So stay tuned, I'm more than sure you are going to get a lot of value out of this video. So first, let's try to understand what exactly this Snowflake Arctic model is. So this is not a language model. This is an embedding model. When we say embedding, an embedding is a mathematical representation of an object or your data, like a word, sentence, or image, as a numerical vector in a high dimensional space. This vector captures object semantic meaning and relationship with other objects. An embedding model is a type of model that generates these embeddings or numerical representations or vectors as they are called. So what this embedding model does is it takes in raw data like text or images and outputs a dense vector representation that can be used for various tasks such as semantic search, text classification, or clustering. These embedding models are normally used in RAG pipeline or retrieval augmented generation pipeline. RAG is used to provide more personalized and grounded data to LLMs, because all of these LLMs, they have no clue, for example, about your personal data. If you want to give the context around your personal data to LLMs, then you need to do the RAG. And if you want to do the RAG, first you need to convert your data into embeddings or numerical representation, and that is where you use these sort of embedding models. There are a lot of embedding models which we have covered on the channel. In fact, 7 months ago I already have covered the previous versions of these Snowflake Arctic models, and if you just search with Snowflake or Arctic, you should be able to find the review of those models, and it was quite good even at that time. Other than that, I have covered a lot of embedding models which you can check on the channel. But let's go back to this embedding model, which is Snowflake Arctic Embed, and see what exactly this embedding model is. So as I said, it is a new addition to the suite of embedding models Snowflake has released, which really optimizes retrieval performance and inference efficiency, especially in a RAG pipeline. The cool thing about this Arctic Embed version 2 is that it is a multilingual, but just by being multilingual, it doesn't sacrifice the performance of English language, which is a limitation of various other multilingual embedding models. This model excels in English and non-English retrieval and has outperformed leading open source and proprietary models on various benchmarks. And that information around benchmarks is already mentioned in this evaluation. I'm not going to go into that detail. It has got quite a good inference efficiency. It is just a 303 million parameter model. It is a 303 million non-embedding parameters. That is why its inference is so fast. It also achieves high quality retrieval with embeddings as small as 128 bytes. That's it. If you already are using any embedding model, this model could be a drop-in replacement because it is compatible with most of the stuff out there. Also, it supports the context window of around 8K, which is quite long when it comes to embedding models. So that is a quick intro of it. Let's try to install it and see how it works. Let me also give a huge shout out to Mast Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. Okay, so let me take you to my terminal. This is my Ubuntu system, and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM, courtesy Mast Compute. You don't need that much GPU, by the way. It's just an embedding model. So for starters, I'm going to create Coda. I always prefer to create conda because it keeps everything separate and nice. Let's wait for this environment to get created. And now there is a change where I install prerequisites normally. Normally I go with Hugging Face transformer, but here if you see I am going with sentence transformer. Let me press enter and I will explain what is the difference between transformers, which is from Hugging Face, and the sentence transformer, which is from Expert. So, and both are open source by the way. So let's try to understand what is the difference between these two in very simple words. Hugging Face Transformer is a broad library that provides access to thousands of pre-trained models for various tasks including NLP, which is natural language processing, computer vision and audio tasks, and few others. Whereas sentence transformer is a more specialized library that focuses on generating embeddings for sentences, text and images. It is designed for tasks like semantic text similarity, semantic search, and paraphrase mining. So you can think of Hugging Face Transformer as a large toolbox with many tools for different tasks, while Sentence Transformer is a specialized tool within that toolbox. And this is optimized for specific tasks related to embedding and semantic search. By the way, you can also use this transformers library to run these embedding models, but I would highly recommend you that if you want to deal with embedding models, go with sentence transformers because it is specialized for that and you get lot of performance and lot less latency with it. Okay, so now you understand the difference between these two. Sentence transformer is still being installed, so let's wait for it. And if you don't want to install it with conda like I did, you can just simply use pip install sentence transformers. And the sentence transformers is installed. Let's launch our Jupyter notebook and then we will download and see how this model works. Let's first download the model, and we are using sentence transformer. This is the model name, and then we are just grabbing this model. So let's run it. And the model is being downloaded, and as I said, these embedding models are relatively smaller, and I believe that this model is slightly on the higher end in terms of size, but it is multilingual. Let's wait for it to get downloaded. And the model is loaded, and by the way, it is not using GPU, it's all on CPU at the moment. Okay, so let's see how this works. So let's first understand what this code is doing. So the code is using the sentence transformer library to perform semantic search on a set of documents based on user queries. And the query is what is Snowflake and where can I get the best tacos. Documents are Data Cloud and Mexico City, of course. And this is just a simple example. Of course, you can replace it with your own full blown text documents or PDF documents, and then these will be the users queries, which could be larger, of course. Now, here we are converting both the query and the documents into numerical representation or embeddings. And once that's done, we are computing the cosine similarity score between the query embeddings and documents embedding using the model.similarity method. So basically that how similar these queries and documents are, or in other words, which query is similar to which document. And then we are looping through the scores and seeing that the code is then ranking the document for each query based on their similarity score and prints the top ranked document along with their scores. So let me run it and see the score. And following is the output of the model. So let's try to understand this. So if you look here, the query of the user was what is Snowflake, and then we provided it two documents. It has given the score on the basis of these two documents. This is first score, this is the second score. If you look here, the first score is higher than the second score because Snowflake is a data cloud. That is why its value is higher than this one. So it means that this document is more similar to this one. So whenever a user will ask a query, the model or the RAG pipeline or the embedding model, whenever the cosine similarity will be done, this will be the preferred answer. Similarly for the tacos, of course, Mexico City is a better choice than the data cloud, and that is why its similarity score is higher. And if you're wondering what this tensor is, tensor simply is a multi-dimensional array of numerical values in PyTorch library. So because PyTorch deals with tensor, so it means that this similarity score has been returned as a tensor object. That's about it, nothing really special about it. Also, in a very rough estimate, and this is just in my own experience, normally you see that when the value of this tensor is between um, 0 and zero point 0.2, it means weak to moderate similarity. When it is higher than zero point 0.5, it is very strong similarity. So you see, it is moderate similarity for both of these. Anyway, so now I hope that you understand how these embedding models work and what exactly this Arctic model is. And now I am going to check its multilinguality. The first example is from Arabic. So you see that I have given it queries and documents in Arabic, and then it has produced this response. Now this is where I need your help. If you're an Arabic speaker, please check these out and let me know if these scores are right. So what it means is that for the this Snowflake one, is it correct, which I think it is, and also for the next one for the tacos. Let's also test it out for Chinese. Let me run it, and I will also show you it running to show you the how long quick that is. You see, again, if you're a Chinese speaker, let me know if it is correct or not. I think it is as per Google Translate, but I will wait for your confirmation. So you have to tell me about this. Chinese looks good to me. Let's try out the Urdu one, which is spoken in Pakistan and few other India and few other countries. So there you go. Yep, sounds good. I think maybe not. Yeah, so I think because Snowflake, I think for Urdu, maybe it's not trained on that one. It is a bit confused around Urdu. Okay, this second one is fine. The first one looks a bit odd. Anyway, let's try out it in Spanish. Let me run this one. And this Spanish translation looks good. Please also confirm if you're a Spanish speaker, of course. And finally, let's try out a West African language, is Yoruba, which I believe is spoken in Nigeria and Benin. Let's run it to see how if it is trained on Yoruba or not. There you go. So yeah, nope. I think it's not trained on Yoruba. It seems doesn't look good to me. But if you are a Yoruba speaker, please let me know. So that's it. Pretty good, I would say, especially for the known languages, and the speed is quite good. The footprint is quite low, and I think it really matches with the sentence transformer. So I hope that you enjoyed it. Let me know your thoughts on it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.